Saturn is sending us mixed signals, mixed radio signals, that is. I'm Marcia Burton, Cassini Fields and Particles Scientist at NASA's Jet Propulsion Lab. Cassini has been in orbit around Saturn for more than 6 years, and new data tell scientists that the sixth planet from the Sun is weirder than we've even imagined. Ever since we arrived, Cassini has been measuring radio waves called Saturn kilometric radiation. Cassini's radio and plasma wave instrument recently determined that the variation in radio waves is different in the northern and southern hemispheres of Saturn. And the northern and southern rotational variations also appear to change with the Saturnian seasons. The radio wave patterns are controlled by the rotation of the planet, so to Cassini, Saturn's radio waves sound a bit like bursts of a spinning air raid siren. We can't normally hear these radio wave patterns, but Cassini scientists have translated the patterns into the human audio range. In this video, you actually hear the radio wave patterns coming from the two hemispheres swap rates over the course of several years. The crossover happened a few months after spring began in the northern hemisphere. Scientists don't think the radio wave patterns indicate hemispheres actually rotating at different rates. It has more to do with variations in high-altitude winds. A recent result from the Hubble Space Telescope also gives us clues. Scientists found that the northern and southern auroras wobbled back and forth in a pattern matching the radio wave variations. The Cassini magnetometer also found that Saturn's magnetic field over the north and south poles wobbled in a similar pattern. These signals are connected because they're all affected by the behavior of the magnetic bubble around Saturn and the Sun's influence on the whole Saturnian system. For those of us watching Saturn, these findings all help explain the complicated dance between the Sun and Saturn's magnetic bubble, something normally invisible to the human eye and imperceptible to the human ear.